This is section 1.1, part B, relationships between categorical variables, conditional distributions. The two-way table contains much more information than the two marginal distributions of opinion alone and gender alone. Marginal distributions tell us nothing about the relationship between the two different variables. So this doesn't tell us, if we think back to whether people thought they would be rich by the time, or more than middle class by the time they were 30. It doesn't tell us anything between the difference of opinion based on gender. We can either look at difference of opinion or difference in gender in marginal distribution. But if we look inside, we can describe a relationship between two categorical variables. To do this, we must calculate some well-chosen percents from the counts given in the body of the table. So again, let's go back to that example where we talked about people who were surveyed, and they were between 19 and 25, and we wanted to know what percent of them, or we had a breakdown of if they thought they would make more than middle class by the time they were 30. So we can study the opinions of women alone by looking only at the female column. So if we only look at this column and we ignore everything over here, then we're looking at stuff on the inside of the table. So to find the percent of young women who think they are more certain to be rich by age 30, the total number of females who were surveyed was 2,367. If we look at almost certain, that's 468. So if we divide that out, we're going to get 0.205, or remember, you multiply by 10 or move the decimal place 2 places to the right. We get about 20.5% of the females who were surveyed that thought they were almost certain that they would make more than a middle class income by the time they were 30. Doing this for all 5 entries in the female column gives us a conditional distribution. It's based on a certain condition. So we're looking at the condition of them being female. So we're looking at the opinions among just the females. A conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable, in this case, that they are female. There is a separate conditional distribution for each value of the other variable. So we could also look at all of the opinions of just the males. We use the term conditional because this distribution describes only young adults who satisfy the condition that they are female. So we need to calculate the conditional distribution of opinions among men. So again, instead of just looking at female, this time we would just look at men. So we would look at no chance, some chance, 50-50, good chance, and almost certain. And for each of those, we know the total number of men who were surveyed was 2,459. Of those surveyed, 98 of them thought they had no chance of being over middle class. Out of the total number of males, there were 289 who thought there was some chance. And we would continue filling that out for all of the males. We would take those values. We would then turn them into percents. So among the males, 4% thought there was almost no chance, where 30.8% thought there was a good chance, and 24.3% were almost certain. There are 2 sets of conditional distributions for any two-way table. So far, we've looked at the conditional distribution of opinion for the 2 genders. We can also examine the 5 conditional distributions of gender, 1 for each of the 5 opinions, by looking separately at the rows of the original two-way table. So instead, we can look across. So if we look at just almost certain, of the people who said they were almost certain they would be over middle class, there was 1,083. 486 of them were female, while 597 of them were male, or about 45% were female and 55% are male. So it seems that the men rated their chances better than the females, because 55% who said almost certain were males, while only 45% who said they were almost certain they would be rich were female. Because the variable gender has only 2 categories, comparing the 5 conditional distribution amounts to comparing the percents of women among young adults who hold each opinion. We can make this comparison in a bar graph. The bar heights do not add up to 100% because each bar represents a different group of people. So, of the people who said they almost no chance, about 50% of them were female. Some chance was about 60%. About 50% of the people who said there was a 50-50 chance were female, and so on and so forth. If you want to compare 2 different categories at the same time, you can use a segmented bar graph. And this is just a graph for which each category there is a single bar with segments that correspond to the different variables. Notice that each segmented bar must total up to a height of 100%. So if we look at almost none, we can see 50% are female, so the other 50% are male. At some chance, female is 60%, so that leaves 40% there for the male. You can see the men part of the bar is shorter than the females part of the bar. When we get down to almost certain, we only have 45% here, so that leaves 55% up there for what percent are male in that category. Our goal all along has been to analyze the relationship between gender and opinion about chances of becoming rich from these young adults. We started by examining the conditional distributions of opinion for males and females. Then we looked at the conditional distributions of gender for each of the given opinion categories. Which of these 2 gives us the information we want? Here is a hint. Think about whether changes in one variable might help explain changes in the other. In this case, it seems reasonable to think that gender might influence young adults' opinions about their chances of getting rich. To see whether the data supports this idea, we should compare the conditional distributions of opinion for women and men. So we need to find the conditional distribution of gender among each of the other 4 opinion categories. Remember, we already looked at almost certain. So if we look at almost no chance, we want to see what percent are female and what percent are male. So of no chance or almost no chance, for females, 96 out of the 194 people surveyed were female, and 98 out of the 194 were male. And again, we would turn those into percents. And you would do that for each of the categories. So almost no chance, they're very, very similar. And we saw that in the segmented bar graph. Some chance, but probably not. Female, of the people who said that, 59.8% of them were female and 40.2% were male. And you would do that for each of the categories.